Hi everybody, so we'll be starting to talk about chapter 6 on normal distribution. First of all, we're going to start the section on the standard normal distribution. Standard normal distribution is a kind of interesting continuous distribution. So last time we have gone over the distribution for discrete random variables very briefly, and we've done some kind of the probability distributions for discrete random variables. On this section, we'll be focusing on continuous random variables and their distribution. And one of the benchmark distribution is normal distribution. Over here, there's one thing that's important is since a continuous random variable has infinitely many possible values, right? It can go infinitely between two whole numbers. It's impossible to give the distribution as a list of every possible value, the way we did with discrete distribution, like listing a table and put all the possible variables and variables and then their probabilities. And instead, we will be using a formula. Okay, we will give the probability in a formula or a certain graph. So that's what we will be doing for continuous random variable in a formula or by using such a graph. Now, as we just mentioned, with infinitely many possible values, the probability of having your variable equal to exactly one particular number is almost zero. Okay, so that's something we need to emphasize for continuous random variable. So the probability that's exactly equal to one particular value is almost zero. So if I put this in mathematical expression, it just tells us that if we have p of variable x, say that is continuous, equals to certain number k, will just be 0. Okay. So the chance of having variable equals to a number is almost 0. Instead, what we do here is we'll be finding the chance or the probability of this variable in between a certain interval, okay, for continuous random variable. For example, we can find the probability of this random variable having a value between -1 and 1. Okay, so let's take a look at the normal distribution and see their characteristics. First of all, question here. Why do we need to study the normal distribution? That's because normal distribution is very useful. Okay, it's often a good fit for real data, such as people's height, weight, and a lot of the other data for normal distribution. It's really a good fit. And based on that, it can be used as the basis for statistical inference, which means you can draw conclusions based on what you have observed from the data. So let's look at the normal curve as we have mentioned before. Okay, normal curve. So normal curve looks like this. Okay, in particular, we call it to be a bell-shaped. Okay, it looks like a bell, and it's very symmetric. It has only one peak on top, right? So single peaked. It's symmetric with respect to the mean in the middle. Okay, remember this mu represents the mean. Okay. So mean. So it's symmetric to the left of the mean and to the right of the mean. The shape of the normal distribution will be determined by the mean. Okay. By the mean and standard deviation. And again, standard deviation talks about how wide the data spreads out, okay? And the mean talks about the center, the location of the center. Over here, the mean can be anywhere. So if your mean is negative, it means it's to the very left of x-axis. If the mean is positive and very big, then it's to the right part of the x-axis. Sigma, as for standard deviation has to be any number that is above 0. So in general, positive values for standard deviation. So that's for general normal distribution. Okay. Now we want to emphasize on standard normal distribution. Okay. Standard normal distribution is one kind of normal distribution that we study a lot. Okay, it is special in the case that for standard normal distribution, its mean will be 0, which means the center will be at 0. Okay, and the sigma will be 1. Standard deviation is 1. Standard normal distribution variable is called z. So if you see the z, you know it's standard normal variable. Okay. It's referring to the standard normal distribution. So 2 key things for standard normal distribution, remember, center at 0 and standard deviation has a value of 1. So let's look at this graph for the standard normal distribution. Again, it is bell-shaped, okay? And this time the center is going to be on the 0. So mean is going to be 0, right, if you draw here. And the graph will be symmetric with respect to this mean at 0, left and right. And the variable is going to be z, indicating standard normal variables. And we can have z equals 1, 2, 3, z equals -1, -2, -3. In general, okay, your bell curve is going to cover a majority of -3 to 3. And then for after -3 and +3, you have very small tails for this bell curve, right? Small tails. But the curve can keep going on and on and on, but it will never reach the horizontal axis. It's important to talk about the area under this normal curve, this area. This area is referring to all the variable that has been covered. So this area will include 100% of the data. So area is going to be 1. And this is a very important character we need to remember for normal distribution. So because the total area under the curve is 1, there is a correspondence between the area and the probability that we'll be computing. Okay. So as we mentioned, we'll be computing lots of the probability of x or z variable that is between an interval. And we'll be using StatCrunch, okay, and it's very easy to use. Let us begin with one question here. There's a typo here. So we would like to find the probability of standard variable z, standard normal variable z, between -1 and a 1. Okay. And I'm going to sketch a normal curve real quick for z. Right? Center at 0. Here is -1 and a 1. So +1. So it's talking about the z that is right between -1 and a 1. If you sketch 2 short line segments to separate -1 and 1, it's referring to this area of the z. So this area would just be this probability that you'll be referring to. As we mentioned before, when probability of z equals to 1, when z equals -1 or z equals to 1, for a continuous random variable, the chance is almost 0, okay, because the area of this line segment equals 1. So if we want to compute the probability of z that is between -1 and 1, it's also the same as computing the probability of z that is strictly between -1 and 1. So the equal sign you can just ignore for a continuous random variable. Alright, so we'll be go ahead and using StatCrunch to compute this. Let's come back real quick. Okay, so first of all, you can go to statcrunch.com, okay, and then you simply just check Open StatCrunch. It will take you to this page. We've done the StatCrunch before, so you should be familiar with us. And next, we just go to Stat, okay, and we want to compute calculators. Okay, use calculators to compute the probability. These are a list of the distributions that are quite normal, quite common to use. In our case, we'll be using normal. Okay, so click normal. So this window will come up, and we have normal calculator on top. And there are 2 ways for us to do 2 options you can pick. One is called standard, one is called between. Okay. In our case, we're just doing the z that is less than or equal to 1, greater than or equal to -1. So that fits between, right? Between. So we can just type mean equals 0 for standard deviation is 1. Actually, automatically it has been filled in, right? Mean is 0, standard deviation. And in that case, your x will just be z, because currently it's standard normal distribution. So you're typing 1 and -1. You may already have that on your window, so that's perfect. So if you hit compute, it will come up with this 0.68268,949. That is the probability that your z is between -1 and 1, which is the area of this shaded region that's between -1 and 1. Okay? So that's 0.6827 if you round up to 4 decimal places. All right. Oopsie. Let's check the, yeah, 0.6827 if you round up. Okay, so let's change this a little bit. So the probability is almost the same as, okay, this is also the same as, okay, let me activate my pen, excuse me. So it equals to 68.27% as well, right, if you use the percentage. Okay, so the shaded area, based on that graph, is going to be 0.6827 of the total area. Remember, total area is 1. Okay. And for this x, because it's already a standard normal variable, we can write it as z. Okay. Let's look at the next question. Let's find the probability of z is less than -2.85. Okay. Less than -0.25. So because it's less than, it's not between anymore. So we pick standard. Okay. So it's still z. We should be doing mean is 0 and standard deviation is 1. Okay. And its z is less than -2.85. So we're going to do editing here, -2.85. Just type that in. Okay. And again, this is going to be your z because it has mean 0 and a standard deviation 1. So hit compute. That's going to give you 0.0022, right? 0.0022. So if we go back to the PowerPoint slides, the probability of z is less than -2.85. It's going to be 0.0022, which is very small chance. If we write this, this is going to be 0.22% of the chance, right? Almost 0, very small. And we can tell that it's this shaded area because it's less than or equal to -2.85. 2.85 is going to be somewhere here, and it's going to be less than. So to the left of it, it's a very small area. And keeping in mind, the entire area is going to be 1, and this is going to be a small area, almost close to 0, right? So next question, let's find the probability of z is greater than -1.24. So if we use StatCrunch, we'll just need to change a little bit. Again, this is still about z. So mean is 0, standard deviation is 1. This time we'll be changing it to positive. It is greater than. So same as greater than or equal to. The value is -1.24. So I'm going to say -1.24. Okay, just make sure you have the right inequality sign. So hit compute. It's going to give you 0.8925, which is this shaded area. And you can see that this shaded area is very big. It covers it covers definitely half of the bell and then more than half of the bell. So it's going to be greater than 0.5, which is 0.8925. That makes sense to us. Okay, so 0.8925. Which is the same as 89.25% if you convert that to percentage, right? So 89.25%. You can also say 89.25% of the data is going to be greater than or equal to -1.24 for a standard normal variable distribution. Okay, let's come back for the next video for more examples for application questions.